All right, here we go. Matrices, section 3. So today we're talking about identity in inverse matrices, okay? And I'm going to we're going to skip some of the sections of the notes. I'm going to share some of the background detailed information. When we were making this notes packet a couple weeks ago, we were kind of debating on how much time we were going to have and how deep we can kind of go into this. The theory behind our kind of mathematics curriculum that we've been using is that we're trying to let you discover and see why things are working versus just telling you, okay? So first of all, let's go through kind of what is an identity. So an identity in math is something that doesn't change the value of the input. So let me give you a couple of examples. The identity for regular addition is 0 because adding 0 does not change the value of the original input. So when we had the equation y equals x, and some of you are like, well, what's the starting point? And I'd say, what can you add to the end that doesn't change it, right? So plus 0 is understood that it's there, okay? You don't have to have it. The identity for multiplication, what do you think is? 1. Because multiplying by 1 doesn't change the value. So that slope of that equation of y equals x, that slope is 1 over 1. So matrices also have an identity, okay? Here's the identity if the matrix has the size of 2 by 2. It's 1, 0, 0, 1. And this is for multiplication. If I wanted to multiply 2 matrices together, and they were a size of 2 by 2, if I multiplied by 1, 0, 0, 1, the result would be the exact thing that I started with. And we're going to verify that right here with a matrix of A, B, C, and D, right? Because it could be A could be any number, B is any number, C is any number, D is any number. Okay, so jot this down. If I'm taking matrix A times its identity, A times I, we'd have the matrix A, B, C, D times the matrix 1, 0, 0, 1. If I take A times 1 plus B times 0, I get A plus 0. When I take A times 0 and B times 1, for that top row, I get 0 plus B. And going to the second row here, I'm going to take C times 1 and D times 0 to get C plus 0. And then the last box down here would be C times 0 and D times 1 for 0 plus D. And so when I simplify that, right, I'm straight back to what I started with, A, B, C, and D. So again, that was multiplying this any matrix, any 2 by 2 times 1, 0, 0, 1. I get exactly what I had. And if I reverse the order, remember how we said the order of multiplication does matter? When I'm working with the identity, I still do get A, B, C, D. Okay? That's your choice if you want to write that second row, all of that out. I'll give you a minute if you want to write it all out. And that's what I just said out loud. You end up with matrix A, no matter if it's A times I or I times A. Those of you that are done writing, I want you to start thinking about the next question that I have posed here. What do you think the identity is for a 3 by 3 matrix? What about a 4 by 4? What about a 5 by 5? Generalize this into any sized matrix. I'll give you a minute or so to think about it. If I was multiplying, it's the idea that I'm multiplying by ones and zeros, right? That I want to output the exact same thing. Draw yourself maybe a 3 at the bottom of the page. Draw yourself a 3 by 3 matrix and start plugging in ones and zeros and see if there's a pattern that you think emerges between what I told you that 2 by 2 matrix was. Any thoughts? I could honestly let you play with this for a long time. Sometimes it just kind of pops out what that pattern is if you start thinking about it. But I don't want us to lose too much of our homework time today. Yes, ma'am.
Would it just be like 1, 0, 1, 0, like repeating like that?
Okay, so tell me what if it's a 3 by 3, what are you thinking?
So like the first row, like across would be 1, 0, 1, and then.
It's not actually going to be 1, 0, 1. It's going to have to be 1, 0, 0, because when I take that first row times all of those other numbers, I want to output the exact same number in that one corner, right? And so I have to take 0 times everything else. So when I go to the second row, what's the first number have to be? 0. The middle number has to be 1. And then 0. Because I only want, think about all that multiplication that we did up here. I only want the A, the B, the C to emerge. So if I restarted with like A, B, C, blah, blah, right? I'd only want that letter to come out in that one spot. So the bottom row, what do you think?
0.
Okay. So diagonally, that's what this red box says. If you ever needed the identity matrix for any size, okay, when it's square, you're going to have ones going diagonal. So if I had a 4 by 4, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Your ones show up diagonal from top to bottom there. Top left to bottom right. All right, so next, identity and inverses. Turn the page here. An inverse. An inverse is something that undoes something. So addition and subtraction undo each other. Multiplication and division. Squares and square roots. For regular addition of the inverse, the numbers are negative. So 5 is, for example, the additive inverse of 5 is negative 5. When we take 5 plus negative 5, we get 0. For regular multiplication, if I want to undo something, I want to get back to 1, I need to multiply by the reciprocal. If you multiply two inverses together, you get 1 when you multiply. So how can you remember that? Okay, if you think back to the identity that we were just looking at, when we were adding, the identity was to add 0. So the inverse is a result of 0. When I was multiplying, I multiplied by 1 for the identity. The inverse gets me to 1. Okay? So here's my example. 2/5 times 5 halves. When I multiply those two fractions together, I get 1. If I wanted the inverse of 6, well, you have to say that's 6 over 1. I'd have to multiply by 1/6. Okay? We have used inverses in trigonometry. Okay, we were trying to undo and go and find those angles. We had sides, we were trying to get to the angles. That was sine and sine inverse. Okay? So in matrices, we need inverses. I'm going to talk to you about why in just a moment. Okay? But let's just look at this real quick. We're not going to actually work this out. If M was a matrix 4, 2, 3, 5, and my inverse, W, X, Y, Z, if I tried to multiply these together so that I get the identity, right? The identity is 1, 0, 0, 1. There's this work that would go along with it, trying to figure out what does W, X, Y, and Z have to be to output this, okay? So what we would do is we would multiply this out, okay? 4 times W, 2 times Y, 3 times W, 5 times Y, 4 times X, 2 times Z, blah, blah, blah. Going through and getting that, and I want that to equal the 1, 0, 0, 1. Basically what we would do, guys and gals, what did we do on our homework today? If I said, hey, what's the value of W? What's the value of Y? I'd have to take that and set it equal to 1, take this and set it equal to 0. We'd have to use systems of equations to work backwards. Okay? So you, again, do not need to write any of the rest of this down. Okay? If I used systems of equations and worked backwards, okay, which would be 4 variables, we've only done 3. You'd have to use elimination twice. And what would happen is that you would get values for W, X, Y, and Z, okay, of 3/14, 4/14. And what would happen is that they would all have denominators of 14, okay? So we would factor that out, and that 14 would be my denominator. If you looked at 4, 2, 3, and 5, how could you get 14? Well, it would be A times D minus B times C. And that's what would happen the whole way through, no matter what 2 by 2 numbers I picked here. I would factor it out in I would multiply A times D and subtract 2 times 3, and that's that denominator that I would get there, okay? So this is what an identity is. I do need you to write this sentence down right here. The inverse of any 2 by 2 matrix, A, B, C, D, is 1 over A times D minus, this is a minus sign right here, B times C. And then in the matrix, you have to flip-flop the location of D and A, and you flip the signs of B and C. Okay? We're going to swap or flip-flop, swap the locations of D and A, and change the signs of B and C. This is something that you're going to commit to memory, and it's going to save you a bunch of work for solving systems of equations. Okay? Everyone have this wrote down? Now the caveat here, and I do have a typo on your notes packet, it's a not equal sign. Can you make that an equal sign, please? We can't divide by 0, like it's not possible. So this always works as long as this denominator, A times D minus B times C, it can't equal 0. Because if A times D minus B times C does equal 0, the inverse does not exist. It's undefined. So here we go. We're just going to practice jumping from here to here, like finding the inverse. So on the example 3, it says find the inverse of t if t equals 7, 4, 2, 3. Check your answer below. Okay? So the first step is to take A times D minus B times C. So 7 times 3 minus 2 times 4. 7 times 3 minus 2 times 4. 7 times 3 is 21. 2 times 4 is 8. Is everyone okay with that? So that is the denominator here. So it's 1 over 13. That's the only math you have to do. And then in the matrix, you have to swap A and D. So the 7 and 3 swap locations. 4 becomes negative and 2 becomes negative. So this right here, 1/13 times 3, negative 4, negative 2, 7 is the inverse of t that we just had. I do not need you to write this down. I just want to show you, okay? If I multiply this times this, I'm going to get back to the identity 1, 0, 0, 1. Okay? So what would happen, we did that scalar multiplication, right? You first multiply these two matrices together, so the 1/13 stays hanging out front. Multiplying these two matrices together, I get this. I simplify it, 13, 0, 0, 13, and I multiply by the 1/13 that's still out front, I get back to there. So all of this work right here is verifying to you that this is correct. So you could do that if you wanted to see if you got it right. But is that mathematics very hard to do? Multiply, multiply, subtract, swap the locations, swap the signs. Like that's a lot of work to check to see that you got the identity correct. But I'm just showing you that it works. Okay? Let's practice one here. Okay? So here is our inverse. 6, negatives, or our matrix is 6, negative 7, 8, negative 9. Okay? What would the inverse be? I'm going to give you about 90 seconds or so. AD minus BC is the first thing you need to do. What is that? AD minus BC. 2. Good job. So you get 1/2 as the number out front. Is everyone okay with that? 6 times -9 minus 8 times -7 is 2. And you can just type it straight into your calculator. Okay? And then you rewrite this matrix by swapping the 6 and the -9 and changing the signs of your 8 and 7. So you're going to get -9, +7, -8, 6. Okay? Turn the page, please. So what is the purpose of learning the inverse? I just kind of shared that a moment ago. They allow you to solve systems of equations without doing all of the work in between. Okay? So if I had this system, 7x plus 5y equals 3 and 3x minus 2y equals 22, we can turn that into a matrix. Okay? And then we can factor out, see how I have x, x, y, y? I can pull that out into a separate matrix. So if you want to write some words down, this is called your coefficient matrix. This is called your variable matrix. And this is your constant matrix. So these numbers are the coefficients that were on the variables to start with. Those are the variables we're dealing with, and these are the constants. So if you don't want to not have to, not that you don't want to, but to not have to do systems of equations by elimination or substitution, you can use the inverse. Okay? So solving a matrix equation using an inverse. So first of all, let's go back up to here. 7, 5, 3, -2. A times D minus B times C is -29, right? So there's my coefficient, and I swap A and D and change the signs of B and C. Okay? So this 1 over -29, -2, -5, -3, 7, that is the golden ticket. Okay? You are going to multiply, technically. Okay, look what this says. Step 2. Multiply both sides of the equation times that. So the first side of the equation was all of this. 7, 5, 3, all of this area right here. All of that is right here. Yes? This 322 is right here. This goes here and here. Now, the reason why this works is every single time this is the identity, and we found it from 7, 3, 5, -2. When you multiply that together, what happened on that previous page? We get 1, 0, 0, 1. Okay? So you do not have to do all of the work on this other side. So if you want to circle this on your paper right here, you do not have to simplify. On your homework today, you do not have to work out this side. All you have to do, guys and gals, is simplify this right here. That is the work that you do, and you will solve your system of equation. You take the inverse times the constants at the end. You take the inverse times those constants at the end. And when you multiply that out, you take these two, the matrices, you multiply that together, and you multiply by that fraction last. Okay, you multiply by this fraction last. When you multiply this, 1 over negative 29 times 116 is 4. 1 over negative 29 times 145 is negative 5. Okay? That is what I wrote here, that you don't have to simplify that side. And that's that this gives you the identity. Okay? Let's practice it once or twice. So on example 4, or excuse me, we're on example 5. I didn't turn my page yet. I went back a page, I should say. Here is our equation. Let's write it out as our matrices. You take your constants and write them out. You take your variables as x, y, and our coefficients, our variables, and then the constants are last. Okay? From right here, we need to find the inverse. Okay? The inverse is A times D. So 3 times 1, type it in your calculator. 3 times 1 minus 4 times negative 2. What do we get? 11, yes. 3 times 1 minus 4 times negative 2 is 11. So that's our denominator. And then we swap A and D and change the signs of B and C. So this is our inverse. You write that as m to the negative 1. Just like we had sine, inverse was the sine negative 1. And we need to take this times what? We need to take it times the 7, 8. And here is what that would look like on your paper. 1/11 times 1, 2, negative 4, 3 times the 7, 8. Can I answer any questions right now before we start multiplying? So we're going to take first row, column, second row, column, right? The 1/11 is going to hang out front. So it's 1 times 7, 2 times 8. Everyone get this right down already? What? When we wrote this matrix right here, we had to change the signs of B and C. You swap A and D, change the signs of B and C. So again, it was 1 times 7 plus 2 times 8, and then negative 4 times 7 plus 3 times 8. Simplify that matrix there. 7 plus 16 is 23. Negative 28 and 24 is negative 4. And now we're going to multiply top and bottom times 1/11. So if you want to use your calculator for that, right, 1/11, you can use the divide sign. So I would do open parenthesis 1 divided by 11, close parenthesis times 23. It's going to give me a decimal on my calculator, right? If your calculator has the fraction to decimal button, you can push that. The yellow calculators, I don't know that I've shown you yet this year how to do that, but hit the math button. It's underneath the green alpha button. Hit math. See how it says option 1 is arrow to fraction? So hit enter and look at your screen. It says answer to fraction. Hit enter again and it tells you that it's 23/11. So it's math, enter, enter, and that gets you from a decimal to a fraction. Now think about that though. Do we have to have our calculator to do that? No. It's 1/11 times 23/1, right? 1 times 23 is 23. 11 times 1 is 11. We just don't want to leave it as, we don't want to round it to a crazy decimal of 2.090909. Okay? Same thing, 1/11 times -4. 1 times -4 divided by 11 times 1, it's going to stay -4/11. And that ends up being your ordered pair solution. Okay? So we take our equation, we write it as matrices, we find the inverse, we multiply the inverse times the constants, and that's your solution. If I'm just using basic 2-variable systems of equations, and this is brand new, some of you might be thinking, why don't I just use elimination? Okay, but think about if I have to multiply by constants and keep going, this is about the same amount of work. But what if we get to 3 variables or 4? If you had a 4-variable matrix or system, this could cut down on a lot of work. Okay, and that's why we have this. So we have 2 examples left in the notes packet. We're going to do one of them together right now, and we'll save the other one. We're going to do example 6. Okay, so let's turn the page here. So I want you to try to start this. Okay, if you need to flip back and forth to example 5, so be it. Take your system and make the matrices. That's your first step. Make your matrices. You could write your homework too.
Does matrices where binary code come from?
They have a lot in common, yes.
Yeah.
Yep. All right, check to make sure you got your matrices wrote down. And now from this one, we need to find the inverse. 4, 7, 2, 1. Find your inverse. A times D minus B times C. Okay, so that inverse you should have got was 1 over negative 10. And swapping A and D and change the signs of B and C. Can I answer any questions about that part? And now what do we do with the inverse? Constant. Multiply it times the constant. Go ahead and start that part. I'll check your work in about a minute. All right, let's see how we did multiplying. Rows and columns. Negative 1 minus 49 and 2 plus 28. And then you add those together, we get negative 50 and positive 30. 1/10 is still hanging out. The negative 1/10 is now ready to distribute or multiply like scalar multiplication. So negative 50 times 1/10. 10 actually divides in nicely here. Negative 50 divided by negative 10 is 5. 30 divided by negative 10 is negative 3. With this 1 being the numerator, you really are dividing by that denominator when you're simplifying. And you write that as an ordered pair. Whoops. Yeah.
So do the variables never go back into the equation?
So you can, like this is your answer here. Okay, you can, where did we rewrote that? Like here. You could have said identity times xy, if you go back to example 5, equaled that over that. But that is that side. So think about all of this work. All it does is reduce to that 1, 0, 0, 1 variables with answers. Okay? Okay, I'm going to tell you that your answer, if you want another problem to practice, your answer is 210 on example 7. All right, we're going to stop our notes there.